Good morning, everyone, and a very warm welcome to the online event of the Food Packaging for a Circular Bioeconomy final event of the YPACK collaboration project on sustainable food packaging. My name is Jackie Davis, and I will have the privilege of moderating our discussions this morning as we hear about the results of the project and the lessons learned, and discuss the way forward to build on the success of this project. After a keynote speech and some presentations to hear about the project and set the context for that discussion. In the discussion and after the keynote, there will be an opportunity for your questions. We're going to start with a keynote to provide some context for our discussions. And I'm delighted to welcome for that keynote, David Newman, who is Managing Director of the Biowaste and Biodegradable Industries Association, BBIA. And I should say, David hopefully will have time to take a couple of questions after his presentation. He's also going to join us for the panel at the end of this webinar, so you have another opportunity there. But David, a very warm welcome to you, sir, and over to you to get us started.
Good morning, everybody, and thank you very much, Jackie, for the kind introduction, and thank you to the organisers for inviting me here today to speak to you and to try to give you some sort of context to understand why we're here and what your project fits into. I'm going to share some slides with you. Okay, so I'm going to try to talk about how YPACK fits into the bigger questions around the biosphere, around the bioeconomy, and some of the challenges and the opportunities we face. There's a little bit of information about me and my email address. If you want to get hold of me after this for any questions, I'd be very pleased to answer them. Sorry, I'm trying to. Right, let's move on. I'm of the opinion that we're living in a period of really great confusion, ladies and gentlemen, because it's a period of transition. And if we think about all the elements that are moving together and sometimes not together, there's a lot of confusion, there's a lot of transition going on. And we're entering into the fourth industrial revolution. We've got to sort out the mess of climate change. We have fantastic new materials and technologies available to us to do so. We're fighting the pandemic. We don't quite know how that works out. Meanwhile, our oceans, our soils, our rivers, and our air are full of pollution, and we're trying to substitute some of that with lots of new sources of energy. And of course, transition also brings losers, doesn't it? Because there are people who will have stranded assets. There's a lot of incomprehension how to move to a new system, and there's a lot of resistance to moving to a new system. So we find that people with those stranded assets want to continue with business as usual. And this leads to a misallocation of the way in which we spend our money, our taxpayers' resources to sort these problems out. So if we want to sort them out, we've got to get some clarity. Now, you all know this very beautiful butterfly. And when we talk about the circular economy, when we talk about recycling, when we talk about material recovery, well, we actually mostly talk about the right-hand side of the butterfly. We talk about what I call the mechanosphere and what I sometimes jokingly call the Lego sphere, because on the left-hand side, there's the biosphere. Now, the biosphere is where everything grows, where life and our food comes from, where our clean water comes from, and it is life-sustaining. But we actually don't understand it because none of us live in the countryside anymore. We're all city dwellers. And because we're city dwellers, we grew up playing with Lego, we grew up playing with toys and putting things in holes and boxes and breaking them up and taking them apart. And we very, very easily understand what the Lego sphere or the mechanosphere on the right-hand side of this butterfly is. It's easy to understand, but actually it's quite difficult and not very sexy to understand the biosphere. It's about dirt, it's about soil. But the biosphere, ladies and gentlemen, is the human sphere. And it's the sphere of life support systems. It's our natural capital. And so when we talk about recycling and we talk about the circular economy, what goes into the mechanosphere doesn't fit into the biosphere, and vice versa. What goes into the biosphere, so organic recycling, materials like you're making here with the YPACK project, actually don't fit into the mechanosphere. But the two spheres are separate. And we have to get this confusion sorted out in our brains and actually understand that the biosphere is feeding us. Mechanical recycling, for example, of plastics, does not. So what we put into the biosphere has to mimic nature, because we want the biosphere to be nurtured and we want it to be restored and to maintain our food systems going ahead. And one very clear example of the nexus between the two spheres is the collection and treatment of food waste. Now, as you know, post-2023, food waste collections will be obligatory throughout the EU. Now, urbanization over the last 200 years broke that bond between man and the biosphere. We all live in cities, and our waste, and our bio-waste, comes to the city and stays in the city. And as populations over the last 2 centuries have urbanized, so the material flows have become linear, because the materials and the products which enter our urban spheres remain there as landfills, remain there incinerated. We tried lately in the last 20 years to recycle some of that stuff, not very successfully, but we actually got very, very little back to the biosphere. And when we do get stuff back to the biosphere, we very often take back a lot of contamination with it. So we have a fantastic challenge and a fantastic opportunity of actually improving the way in which our urban spheres interact, promote and nurture our biosphere. I hope you're not getting confused with all these spheres. We're losing around 15 million tonnes a year of topsoil across the EU. And at the same time, stupidly, we're sending still 50 million tonnes of food waste to landfill and incineration. Call human beings intelligent, but this is really stupid. It contributes to climate change and is a waste of resources. We know that, so we've introduced a law that all these bio-waste materials must be collected separately and go into treatment. That's great. We're going to get all lovely stuff from it. It will help with greenhouse gas emission targets and produce a lot of nutrients for our soil and restore some of that soil-to-soil loop that urbanization broke. But to do that, to make sure we get through and back to the biosphere materials that are useful and nurture and restore the biosphere, they have to be clean. And if we look at food waste currently across the EU, we're actually putting back into food waste treatment a huge amount of plastics. We are getting a lot of plastic impurities in our food waste. For example, in Italy, where I'll come to that in a minute, they got it sorted out. They have very low impurities, but other countries have as much as 5 up to 15% impurities in their food waste. And so that's a huge economic cost to the food waste disposal system. Billions of euro a year will be paid to take that plastic out and incinerate it. But it's also a huge environmental burden that we're putting back to the biosphere, because we're putting back to the biosphere tens or hundreds of thousands of tons of plastic, which we cannot get out when we receive them in our compost and our anaerobic digestion plants. So we talk about nurturing the biosphere and restoring the biosphere, but if we don't do it properly, we're actually going to worsen it. So the Italians got it sorted out. I helped write the law 10 years ago, which said that food waste should be collected with either compostable bags or with no containers at all. And we need to have a review of the fertilizer directive. Now, this is going a little bit out of the discussion around YPACK, but it's very important to note that unless we get biowaste collections right, the role of materials, like the materials you're making in BioPack, don't fit into the biosphere. And what we really need is healthy soils, really healthy food, healthy people, and a healthy planet. And this is why the environment, the biosphere environment, is so vital to our future as a species on this planet. So the materials that we use to get the biowaste back to nature must mimic nature. And these are the materials that you're making in YPACK, compostable materials. You may call them biodegradable, but materials that do not harm soil. And the role of these materials is not to enter into the mechanosphere, but actually to mimic natural materials and go back to the biosphere and take with them back to the biosphere the biowaste which they can carry. you have to answer one question when you think about this, ladies and gentlemen. How are you going to get 50 million tons of biowaste back to soil cleanly every year without plastic pollution? You need materials that mimic biowaste. But there's a lot of confusion. And as I said earlier, confusion is often a reason to do nothing. It maintains business as usual. And there's a lot of confusion even in the European Commission. On the one hand, huge amounts of money going into investments to make innovative materials. On the other hand, legislation banning their use. It's really confusing. So we need clarity. And we need to understand that the materials that are going into the biosphere are materials like you are making here, and they accompany biowaste back to soil. A few quick slides, because I know I'm getting short on time. There's a lot of confusion around legislation. I won't read that to you here. You know it yourself. Plastic taxes, carbon taxes, definitions, and the whole thing around the legislation on plastics at a regional, national level. I mean, I really can't make any sense of it. It really is very confusing. I feel very, very sorry for brands who are putting materials onto the market. It must be hard for them too. There's a lot of confusion around technologies. We have now, miracle worms that eat plastics. We have chemical recycling. We're going to sort all these things out with technologies, and everybody's looking for that fantastic silver bullet, aren't they? Well, I'd be quite honest with you, there ain't one. There is no silver bullet. And if you read the Breaking the Plastic Wave report by the Pew Charitable Trust, which came out in July, you will understand it. There's a lot of confusion around pricing. People talk about compostable materials and your YPACK materials as alternatives to plastic. You're wrong if you do that. You can never compete with plastics. Plastics are now costing, coming out of China, at $600 a ton, a third of the price of 3 or 4 years ago. And the scale of plastics production is rising. And of course, plastics are a fantastic material. They work just fine until you have to dispose of them. And of course, forgetting about all the emissions, their toxicity, their contamination, and the failure of recycling. And the mechanosphere, when we talk about waste and disposal markets, is really a mess. Plastic recycling markets, I predicted 10 years ago, would die. They're dead, effectively dead, and it costs twice as much today to recycle PET and make materials out of it than to make clean new PET. So export markets are closing down, and recycling of plastic, I'm sorry to say this, and I'll be very clear about it, is a scam. What Mr. Trump would call fake news. There is very, very little plastic recycling going on globally. It's maybe 7% of all plastics. But we still insist, and we still think our way out of the plastics mess is plastics recycling, and we still use plastics to contaminate our biosphere. We are not a very intelligent species sometimes. So that means there's a big future for incineration. They're even talking here in the UK and certainly in the United States of reopening landfills. There will be some recycling if we heavily subsidize it. Maybe we'll have lots of plastic park benches sitting around and waste bags, of course, and some things can be done. But really, stop thinking that plastic recycling is our way out of this. So we're misallocating a lot of our money because we're putting a lot of money into subsidizing the fossil fuel industry, which is plastics, but we're not putting any money into subsidizing the biosphere, which is our life, which is our food, which is our air and our water. How can we not subsidize that? But actually subsidize incineration, subsidize plastics. It's obscene. The circular economy is not for free, and it's not, the biosphere is not for free. We have to work on policies to privilege it. Have a look at the Breaking the Plastic Wave report, ladies and gentlemen. It's a fantastic report, came out in July, and it shows how compostable materials like you're making in YPACK are just one of the routes that we need to take to stop huge amounts of plastic going into the oceans. If we take all these routes together, we can perhaps reduce 80% of plastic pollution over the next 20 years. But there's not one route that does it all. We have to do everything. In the UK, the UK government, or the RAP, which is the Government-Backed Plastic Pact, used in February, published this report on the use of compostable materials that can go back into the biosphere where they are suitable. Now, your materials fit into these uses here. And we have to get this sorted out, because if we continue to use plastics for these materials, all we're going to do is continue to pollute the biosphere. So, a brighter future? Well, Jackie, if we get a grip around this and we stop playing with Lego and we move on, we're adults. Let's look at where our interest is as human species, and our interest is in the biosphere. And we need food waste and packaging that can go to composting and go back to that biosphere cleanly. We're still in the EU just ahead of the game, okay? But our focus here is still confused. China got its focus sorted out, and from next year, the use of compostable materials in packaging is a national legal obligation from 2021, because it is understood the failure of plastic recycling, but it's also understood that the biocycle, this biosphere, needs to be privileged. Some suggested reading to take away from my 15-minute rant. There's a wonderful new film called Kiss the Ground on Netflix. It talks about the restorative value of soil and how we can solve most of our climate change issues by restoring and nurturing our soils and by composting and getting our biowaste cleanly back to soils. And there's a little book I wrote as well, which you can find on Amazon. It's an ebook, which talks about all these things and how they're all connected up. And if you have a wet, cold weekend ahead over the next weekend, it's fun reading. Jackie, that's all from me. Thank you very much for your time, ladies and gentlemen. Thank you for listening to me.
Thank you very much for such a rousing and challenging start to our conversation today. As I say, David has got time now for a couple of questions. If you have any, either through the Q&A box or put your hand up and I'll give you the floor. But I just wondered, David, if I could ask you a question. You talked a lot about confusion, and confusion in a number of areas: definition, standards, legislation, the technology, the pricing. Why do you think there is so much confusion? Because that maybe helps us to understand how we can overcome it. What's causing this confusion?
2 weeks ago, a report was issued showing how the major soft drink companies, and I won't name you them, but they are Pepsi-Cola, Coca-Cola, Mondelez, Unilever, Procter & Gamble, have deliberately for the last 30 years told us a story, knowingly lying, that recycling was the way in which we citizens would solve the problem of the materials they put onto the market. It was a deliberate PR strategy. We have all the documents. We know that. And so by sowing this confusion, making citizens think that, okay, we put that into this bin over here, we've solved the problem, they've actually maintained business as usual. And we saw exactly that process with the tobacco industry, Jackie. We've seen exactly that process with the oil industry over climate change. So doubt, so confusion. Talk about standards. Talk about, biodegradable plastics pollute plastics recycling. What nonsense. We make 2 million tons of biodegradable plastics. They make 400 million tons of plastics. Who's polluting who? But no. So we talk about how these are going to pollute plastics recycling streams. What utter nonsense. But it's all about sowing confusion to maintain the business model.
Thank you. And Tanya Radusin asks, how do you think that high plastic load will be solved without recycling? Because biosolutions are still far from mass produce and mass usage.
If you listen to what I said that the biocycle solution is one of 8 different pathways which the report laid out are necessary to stop massive plastic pollution. They are just one part of the solution. There is some role for these materials in substitution, where they can go back to the biosphere, where they can take food waste back to the biosphere. It's only one part of the solution. If you read the report, you will see what the other 7 are. Refill systems. They don't catch on. We have them in a lot of places, but they're not very popular. But we must make them more popular. Banning and prevention. Actually, do we need plastic bottles? It's I mean, I grew up without them, but that's a question we have to ask. And so there's lots and lots of pathways, and the biomaterials pathway is just one of them.
Thank you. Karen Mahone asks, David, if a biopack material is designed to mimic the natural biosphere processes, are we not in danger of producing something that disappears from view, but at a nanoparticulate level, the residues from bioplastic within current CEN stands up to 70% from fossil fuel polymer chains, this one's a bit longer than Twitter length, but hey, may in fact be taken up more easily by soil, biota and plants mimicking nature, though at cellular level actually damaging the biosphere. David?
Well, I'm not a scientist, but Bayreuth University published a report back in 2018 in which they looked for microplastics of various types going to soil, and they found absolutely zero evidence of any microplastics going to soil from compostable materials. There is now today a soil biodegradability standard, so that materials going to soil, if they go with fragments, will continue to biodegrade and mimic natural materials. If you think of a tree, Jackie, well, a tree is made up of trunk, branches, and leaves. Now, if you cut a tree down, it will take 50 years for the trunk to biodegrade. It will take 10 years for the branch to biodegrade. It may take 2 weeks for the leaf to biodegrade. So you have to look at the materials in that sense. But there is no evidence that compostable materials in any way, shape, or form bioaccumulate.
Okay, on that note, David, for now, thank you very much indeed for such a rousing start to our discussions and for setting out the challenge so clearly. I want to come back in our discussion with the panel later on all those issues you raised and explore ways forward and how we address some of those challenges. But for now, thank you very much indeed. The audience can't applaud you, so I will do it for them. Thank you. What we're going to do now, ladies and gentlemen, is we're going to have a short introduction to the YPACK project. I'll introduce our speaker in a moment. And then we're going to see a video about some of the challenges the project faced, some of the results, and then hear about them in more detail in a series of short presentations. So I'm going to give the floor first to Jose Maria Lagaron Cabello, better known to many of you as Chema. He's the YPACK coordinator. He's from the Agencia Estatal Consejo Superior de Investigaciones Científicas. Forgive me if my Spanish pronunciation isn't so beautiful. Chema, over to you, sir.
Okay, good morning. Thank you, Jackie, for the nice introduction and for helping us to take this webinar through. Thank you also, David, because you have made a fantastic job of putting the different arguments into the scene. We will now briefly, because we don't want to overload people with technical data, etc. We are just trying to fly over some of the concepts and technologies that we have developed in the line of thinking that David was proposing, this alternative road of biocircular economy, organic recycling. So the YPACK project is entitled Minimize Food Waste by Applying High-Performance Biopolyesters-Based Packaging. It is an innovation action of the Horizon 2020. So it's been a 3-year project in which we have been trying to achieve this sort of a proof that will show that there is an alternative to mechanical and chemical recycling. Okay, so we know that out of all plastic waste, around only 31% at the moment is being recycled. We also know that around 8 million tons a year, which accounts for about 3% of all waste, ends up into the ocean. And we also know that at least 1/3, which is really a shame, a figure, 1/3 of all food ever being produced ends up into waste. So we are really not very efficient at the moment in all of these things. And YPACK actually collects all these challenges and has been working very hard trying to propose alternatives so that we would offer new routes to fight these appalling figures that I have just discussed. So the project intention was to really deepen into the concept of the circular bioeconomy beyond the circular economy, which is mostly thought of as mechanical recycling. We do not believe that mechanical recycling, as David was pointing out very cleverly before, is going to be a sustainable solution. And if we just look at one simple example, so PET can be recycled around 7 times, mechanically recycled about 7 times before it begins to degrade and cause issues that could generate food safety problems. So in an environment, in a scenario where where mechanical recycling will take place, how can we guarantee that every pellet that comes into the factory that produces the packaging will actually not have been processed or reprocessed more than 7 times? And we're talking here about PET, which is the ideal, let's say, petroleum-derived plastic that is today the biggest or the highest or the most adequate candidate for mechanical recycling, and there are many other plastics which are still uncertain as to what level they can be really mechanical recycling. And then there is, of course, the more sustainable way, which is the chemical recycling, in which we bring the polymers back into the monomers and then we build them back into the reactors. This solution could actually be a solution that could be sustainable, but as David was pointing out, this is already at the infancy. So we still need many years to really try this technology and bring it into the market. So we are probably 10 years ahead or even longer. And then still there is the issue that if we are not able to collect the products that end into the environment, we will still keep contaminating with these long-lasting products, right? So the project intention was to take waste components, use them to feed microbes that they will produce polymer. With these polymers and some additives that are also compostable, make 2 packaging items that by combining them in different ways, we would be able to tackle a lot of different applications of food. Then in this scenario, of course, we know that we are going to be more expensive. So we wanted to really reach out the niche applications in which packaging is actually being paid more, which are the shelf life demanding applications. And for that, and knowing that this has been always a problem in the bioplastics, that the industry has never really perceived them as a solution for the high tech or the niche applications in packaging that demand high properties for them. We, as I said, intended to convert this biopackaging that we were developing in really performing materials. So we have developed strategies for active and passive solutions in which high barrier biopackaging would be developed. Of course, we need to prove that whatever we do actually makes sense from a life cycle viewpoint. And then also product validation, where we introduce in several retailers and food companies some foods into our packaging and then really trace them along the shelf life and see that we have an improvement. And this is currently what is going on at the moment. And then we will end up, or we have ended up doing also the assessment of the end life of the packaging. So we have been analyzing the biodegradability or compostability nature of the materials by assessing industrial and home composting, but also soil and marine biodegradation. Eventually, the fullest scenario for this packaging is to be back into waste. And this is then when we close the circle. So the main objective of the project, the research was already out there. It was being going over the last few years by other projects, but also in national and European projects. So there has been, I think, about 15 years or 20 years of research accumulated in Europe into this strategy. All these concepts were available, and what we wanted to do in the project were to prove they can be really scale up into a production. So the scope of the project is 4 tons production of packaging. And then, of course, we had to do all the techno-economical validation of these elements and then prove again that they can be substitutes of high-end packaging applications. The project is set to be successful right from the beginning because we have gathered a an international team of partners from different countries. And this is actually what is shown here, the partners that have been doing all the work together. In fact, there are very, very little RT research and development partners in the project because, as I said, the intention was to really prove the scalability and the industrial scale of this technology for the first time, as far as I'm aware. And there are a lot of companies, SMEs, all along the food chain, SMEs, some RTDs as well, medium-sized companies, and also large companies, including food packaging producers and retailers and food industries. Yes, I'm about to close up. So the idea here then is to produce a number of components, to mix them up, to convert them into these 2 packaging elements and to analyze them and bring them back into waste so that we can prove the full circularity of what we do. The key to success to the project, of course, is that we have been doing all these different tasks by these relevant partners, including consumer profiling and market trends, concept testing and product validation, support of regulation and risk analysis issues. Even we have assessed responsible research and innovation actions, and then of course finally that the costing was actually making sense, and then the idea was to actually bring them into the market, and then we have done so. We have developed 2 concepts: thermoformable, rigid, compostable tray. We developed 3 grades for that. One of them, the YPACK 23, is ready to go to the market because it is made with food contact materials already. 25 and 27 actually contain the elements that we have incorporated in the project, and they will have to be validated by EFSA, etc., to be in the food contact list. Then again, as I said before, we developed not only the rigid tray, but also the film that could be used for lidding and for flow packing. And this film has been developed in 3 ways, in 3 concepts. One of them is just the monolayer. The second one is the high barrier multi-layer film, and the third one is an antimicrobial high barrier multi-layer film. And then by combining all these elements again, then we are aiming at the final message that I would like you to take home with, is that the organic recycling packaging is a feasible route to resolve some of the issues that David put forward in his presentation. So we start from waste, we valorize it, and we bring it back to waste. We don't compete with food, etc. So thank you very much, Jackie. I bring that back to you. Sorry for extending.
No, not a problem at all. Thank you so much for that, Chema. And 3 years of hard work summarized in 10 minutes is no mean feat. We're going to hear in more detail about some of those stages and those keys to success, the different aspects that you looked at a little bit later on. But thank you. And Chema will be back for our panel after the presentation. So if you have any questions for him, we'll take them at that point. So thank you very much. To complete the broader picture before we go into some of the detail, as I mentioned earlier, we wanted to show you a little video just outlining some of the challenges and some of the results that came out of the project, and then we'll move to the presentation. So first of all, let's watch that video.
YPACK is an innovative EU-funded project that has developed biodegradable food packaging that also extends shelf life. As the project nears its end, here YPACK partners share about the 3-year collaboration work.
Important,
challenging,
exciting,
investigation,
collaborative,
inspiring,
successful,
innovation,
insightful,
rewarding,
and very friendly.
What I found more challenging about this project was to collect so much data from consumers and other stakeholders, and also to be able to make sense out of the data and figure out what would make this great packaging be out there in the market very soon.
Mostly to align the different agendas between retailers, researchers and also the packaging industry.
Ensuring the scale up of the packaging and then the validation.
Really prove that concepts and technologies at research level can be useful and taken into the next level for industry.
To assist the birth of this new technology and new products is always a fantastic experience, but challenging at the same time.
The results of the YPACK project really enabled us to test new packaging, compare it with existing food packaging, understand the differences, understand the behavior of the new materials, and that's really important to drive new solutions to the market and to drive innovation forward.
We have optimized the technology to produce food packaging by extrusion and thermoforming.
The results are promising.
Working on a project with the importance of YPACK, together with partners from many different areas with different skills, has been really rewarding, and bringing all those competencies together to drive innovation and drive new solutions to the market, it's a privilege.
To change the whole concept of packaging, and these new bioplastics will bring, I hope, a new era for food packaging as well as for other packaging technologies.
YPACK could additionally offer benefits over conventional packaging solutions in very specific and niche single-use applications.
Addresses the consumers at the very end.
By addressing all issues of market trends on sustainability, life cycle analysis of the materials, the care put into the validation stage will definitely ensure that YPACK solutions will be the right alternative on the market.
YPACK. Reduce, recover.
So there you have it, ladies and gentlemen, and you're going to hear from a couple of the people in that video in our presentations now. So as I say, we're going to take you through some of those key aspects of the project that were outlined by Chema a little bit earlier on. And I'm delighted to welcome for the first of those presentations, Antonio Vicient, project leader at the Universidad de Minho, to talk about the upscaling challenge, upscaling the YPACK technology. Antonio, very warm welcome, sir. And over to you. And if you could share your screen and start your presentation, that would be terrific. Thank you.
Thank you, Jackie. And thank you, everyone, for being there and for listening to us. I'll now try to share my screen and see how is it going. Yeah, it works. So let's go. Well, this is me. I know you've seen me before, right on your screen. I'm with the University of Minho in Portugal, and really what we would like to know is it possible to produce our biodegradable packaging materials at industrial scale? Samuel just put it very straight on the last video we've just seen. And from my side, I would like to let you know that most of the science behind YPACK was really on the shelf, ready to be used before the start of the project. And this is the result of previous projects where many of the consortium members participated. And this was mainly the cause of the success of the project, because the early developments take many, many years of efforts, and as Chema just mentioned before, and in our case, this was crucial. Otherwise, we could not be able to proceed as we did. So we knew how to obtain the biodegradable ingredients used in YPACK packaging solutions from byproducts of the food industry. PHBV, which is the main plastic material used here, is produced by bacteria that grow on very diverse substrates, including cheese whey. You can see on the top right-hand corner a photo of these bacteria, and you see the little white dots, which are the plastic material that can be then converted to food packaging. The fact that we need to take them out of the bacteria, so this material out of the bacteria, and the fact that we need to purify them were really two challenges, but I will do that right away. Then the other issue are the almond shells. So they are very rich in cellulose. This is a perfect filler to complement the composition of the packaging materials, and actually just needs grinding to the appropriate size, so it's there. We also had clues on how to actually process these materials into packaging materials and how to tailor their properties according to the intended function. We knew the range of temperatures, pressures, and other processing parameters that should be used to obtain a film and a tray with the adequate properties. So we knew all these. What was the problem? The problem is that we are able to do this, or we were able to do this only at lab small pilot scale. And we could produce a few meters of film, we could produce a few trays, but not at the 4-ton range that Gemma mentioned before. And also, we did not know how the materials and systems involved would behave when using industrial scale technology. This was another problem. And in this case, being technology the limiting factor, we had two main challenges. The first one was the lack of sufficient amount of ingredients. So we needed upscaling the ingredients production and their purification. And the other one was the lack of knowledge on how would these materials behave when processed at larger scales, so that they could be processed in the existing facilities. You can't go to a company and say that their €1 million equipment is no longer valid to process these materials, and then they need to invest as much in new equipment to process new materials. This can't be done, otherwise it's not going to work. So we had these two major challenges to take forward. The first one was addressed, which we established a large pilot scale production system for PHBVs, so for this bioplastic material by fermentation of cheese whey. And you can see here a picture of a few of the containers that have been produced and sent over to purification. So this means that our challenge of knowing how to purify the material to the adequate level, and this is well over 95%, was also addressed and achieved. Then we had the second challenge, and this was not the least of them, because we were able to formulate mixtures containing the purified PHBV, so the purified bioplastic, and the almond shells and other ingredients. We formulated those mixtures, and we established the correct processing window, which is really a hard balance to reach for the formula in order to obtain compounds able to be further processed. So for those of you who are not very well acquainted with this type of processing, we need, first of all, to have this compound, as you can see in the picture, and then this compound is going to the machines to be extruded or thermoformed. And this is, of course, a crucial step. If you can't produce the compound, then you don't have your ingredient to the production of the packaging materials. Which means, still in the second challenge, that we need to establish the adequate processing window also to produce the film and to produce the tray. Here you can see a picture that Gemma showed before as well, with a machine that is blowing the film bubble that will make the film in order to be used wherever needed. You see the rolls that we have produced, or a few of them. We have produced much more. And we also were able, so as I said, to establish the adequate processing window, that is pressures, temperatures, etc., to obtain a compostable, biodegradable film and tray with the adequate properties, including barrier and active packaging properties for the products that we chose as case studies in YPACK, and we'll be seeing that later on. So as I said, here's our compostable, biodegradable film, and here is our compostable, or here are our compostable and biodegradable trays. You can use them, they are really nice, but we developed a fully biodegradable barrier film and trays. They are ready to be produced at larger scale, but now we need to know a very, very important thing. Are these acceptable for the consumers? This calls for validation in a real context of food packaging first, and Anna will let you know that right away.
Thank you. Before we move on, we weren't planning to take questions, but there's a very quick one, Antonio. So if I can put to you, Cheese Whey, says Horst Christian Langowski, is a highly valuable product and can be used by itself. It doesn't make sense to use it as a substrate for bacteria. Why did you choose Cheese Whey?
That's true, absolutely true. And there's been a lot of efforts to valorize Cheese Whey as a component, for instance, for consumers who are training in the gym and they need it to as a supplement of protein. And there are many components in Cheese Whey that are really highly valuable. What we need from Cheese Whey actually is the lactose. So that's the sugar that is needed to grow the bacteria. And it was simpler for us to use Cheese Whey right away, but if we need to extract those components first, those valuable components that Horst Christian talks about first, and then use the lactose, that will be perfectly fine. In the case of simplicity, and for the sake of simplicity, we use Cheese Whey alone.
Okay, we're going to have to move on now. Sorry, I'm seeing another couple of questions, but we really do need to move on. So thank you very much indeed, Antonio. Very grateful for you. And as you say, we're now going to turn to taking YPACK to market. And you saw her in the video. You now get to see her live, Ana Machado Silva. I will, just to say, I will try to take those questions at the end if we have time before we move to the panel. But Ana Machado Silva is Senior Project Manager at Sonai, and over to you.
Okay, thank you so much, everyone. Good morning. Thank you for joining us. Thank you also to all of the YPACK partners that I'm sure are here also attending. Let me share my presentation so that I can pick up from where Antonio left and really explain how we are bringing the science and technology that Antonio thoroughly explained, how we are bringing that as closest to the market as possible. So as Chema explained, we are within YPACK developing and validating packaging solutions that we really believe can be an alternative to some of the conventional packaging that we're currently using. So what we're doing in terms of validation, so we're taking those films and those trays and we're using them in different geographies to pack real food items and then understand the behavior of the material and other aspects that I'll share with you. So we are really comparing conventional solutions with the YPACK solutions, and to really understand the differences and really validate, let's say, the hypothesis that we've had within the YPACK developments. So why do we believe that validation of the solutions in a real context of food processing is important? Because as Chema explained, as Antonio stressed also, we really want to take these new solutions and test them within the industrial processes, the equipment, the conditions where this packaging is traditionally used. So this was something that we detected in YPACK that was lacking from previous projects due to time, due to resources constraints. And so we really wanted to push forward this. So we're using different types of food items with different needs in terms of conservation, with different characteristics, with different usage modes. So some are eaten raw, some need to be then processed and cooked. So we selected meat, pre-cooked pasta, both refrigerated and frozen, and fruits and vegetables. And for each of these food items, we are taking the right packaging solutions from YPACK, and we are comparing them with the conventional packaging. And we're using this with different combinations. So for example, we're using the YPACK trays with conventional film. We're using the YPACK film with conventional trays, and then we are combining all YPACK solution. So this gives us also the opportunity to understand not only the isolated effects, but also the combined effects, which we believe are important also to then understand the impact of the project and of the solutions developed. And we're doing this using an iterative process where we receive at the side of the food processing companies, food retail companies within the consortium, we receive the packaging, we do visual inspection, we do the initial testing, sealing conditions, and other important testing. We see the behavior on the food packaging equipment that we have, and then we take that feedback back to the partners from the packaging industry. And if we detect something that needs to be fine-tuned, then we will do that within the YPACK consortium. Let me give you an example. For example, for one of the batch of the trays, we detected some pores, and those might be a problem when we're packaging food items that, for example, need high barrier, such as meat. And so we've tested them in the food packaging lines. We incorporated the feedback back to the packaging partners, and they're now detecting what might have happened, and they are producing a new batch of trays. So we really want to do a stress test to the packaging solutions within the work package of validation. And Gemma already explained that not only we are looking into the conditions and the performance of the material per se in the food packaging lines, but we're also looking into the effect of the new YPACK packaging in the shelf life of the products that we are using as, let's say, use cases to demonstrate the technology. So meaning that we have different products such as meat, such as fruits and vegetables, or refrigerated and frozen pasta. So expectations on shelf life, timing and behavior, very different. Degradation conditions or causes very different as well. So we're really looking, and we're at the moment conducting the shelf life studies also, again, to validate and to have valid results from the technologies that we are developing. And so we are taking more sustainable packaging solutions as close as possible to the market. But as Antonio already said, we also have a question here, which is, so will consumers accept and understand these new packaging solutions? And to answer that, I'll leave you with Bettina to present some of the results that we already have from the consumer studies. Thank you.
Thank you very much indeed, Anna. So as you say, let us move straight on. There are no questions at the moment to your presentation, so let us move straight on to Bettina Bequiras-Visman. She's project leader at Wageningen University. You saw her in the video. You now get to see her live. She is going to share her screen, and away you go, Bettina.
Good morning, everybody. Yeah, do you see my screen? Yeah, great. Yes, good morning, everybody. Indeed, as my colleagues have already mentioned, when it comes to launching to the market a new disruptive product, investigating consumer acceptance is of utmost importance. And in this project, we explored how consumers would accept a novel sustainable packaging solution such as the one that YPACK proposes. In this particular case of new sustainable packaging, not only do consumers have to identify it in the shelves and be willing to pay a premium if needed, But also at home, they have to discard it properly. And this involves changing the way in which consumers behave at home and also in the supermarket compared to most conventional food packaging. So that's why it's so important to investigate not only what consumers know and understand on these matters, and this is particularly what made this project very, very interesting. So what we did is, in a series of online studies across 7 European countries, we asked several questions about consumers' correct practices, attitudes about sustainability in general, and also plastic packaging in particular. And this information would let us know what people around Europe currently do and understand about and perceive sustainable packaging. So what we did is we presented them a total of 8 packaging designs. These were simply described, made out of the combinations of characteristics that the YPACK solution has. So that is being bio-based, compostable, and having these different types of technologies to extend the shelf life. So consumers had to evaluate each of these designs descriptions in terms of willingness to purchase, and also on a set of attributes such as, for instance, what you see on screen: it's sustainable, keeps them food fresh, being of good quality, naturalness, convenience, and so on. There were many, many questions, but I will just not go into details for the sake of time. So I will just present you some results, some highlights of the results of the studies. So here, for instance, you see a selection of benefits perceived after the YPACK attributes were described. And as you can see, which is perhaps the most obvious, is that the impact of into the environment and waste reduction, waste in the first place, and keeping food fresh for longer, the taste and nutrition was a bit lower, and affordability was in the last position, indicating that consumers expect it to be perhaps more expensive than the readily available solutions. We also asked about a number of other items, such as, for instance, indeed willingness to buy, the overall attitude they have, social norms, perceived availability. And in general, we can say, and we observed that the ratings were very positive for all 7 countries. Actually, there were no differences between the countries. Thanks to the psychographic and socioeconomic data we obtained from consumers, we were able not only to identify and quantify groups of consumers that had similar patterns in terms of willingness to purchase, but also we were able to describe each of these groups and therefore know who are the potential consumers. Among one of these groups, of course, there was one that was the largest, 39% of consumers, who were the indifferent ones, we call them, simply because they reported to be less engaged with sustainable topics and also less engaged with waste reduction practices and individual responsibility, as well as little value for naturalness. When we digged into the data a bit more, we saw that this could be related to the fact that these people reported to be having less subjective knowledge on these matters. And currently, additional studies are underway, and these additional studies are looking into how this packaging design can be optimally designed. And what we're actually looking at is what captures consumers' attention, whether sustainability, among other attributes, is quickly inferred, and which claims work best to encourage shopping and correct disposal after usage. At the end of the day, what David and my other colleagues said is a big part of the task is in the consumer's hands. So for this purpose and to bypass COVID restrictions, we created these virtual designs and we did online studies in 3 different countries. So what I'll share next is some preliminary results. But what you can see on the screen already is that the color and the claims used were the key elements in these designs. So regarding correct disposal, we saw that when the claim is a bit vague, such as, for instance, eco-friendly packaging, most people indicated that they would discard in the plastic recycling bins, mostly for white and black packages. However, the most explicit label, which said packaging made from bio-based materials and fully home compostable, increased the choice of the organic waste considerably and decreased the option of the plastic recycling bin. Regarding the PAC's color, the brown color implicitly helped people to identify with the organic waste. However, it was the black color what was associated with more premium attributes, which is what we currently see in the supermarket. So all in all, the preliminary conclusions of this study is that the claims, regardless of the certified logos, which were present in all the alternatives, was more important than color to communicate environmental friendliness, but color really helps as a nudge for correct organic waste disposal. So all in all, the packaging proposed by YPACK has great potential in the market. And what we see is that education and good communication is key for this to really work. And as far as I know, this is the first study that has studied consumers' acceptance of sustainable packaging, plastic packaging in such a comprehensive way. But there's many more results, so please stay in touch and I'll be happy to answer any questions.
Thank you very much indeed, Bettina. Fascinating results there. There was just one question, and it came initially to Antonio from his presentation, and we have a couple of minutes. So, Antonio, perhaps I could put this one to you. Could we list all the constituents of the bioplastic, apart from the cheese whey and the almond shells? What else is in there, was the question.
I'm afraid I will not be able to answer that because it's being under protection. So, but what we can tell you is that apart from those constituents, we have also worked with some other products, some other types of additives, also bio-based. And those are the ones that Shema mentioned that are now being posed to the EFSA for licensing. And that's the reason why I cannot let you know much more about it. I'm really sorry about that.
No, but thank you. Good to have taken it up and good to explain why you didn't say more about that. So thank you very much to all of you for that whistle-stop tour around very, very in-depth work that's been done and fascinating results in a number of areas. I want to discuss those results and the lessons learned and where we go from here with our panel. So to discuss with me challenges and opportunities for compostable bio-based food packaging for food products, I'm delighted to welcome Chiara Pocatera, who is coordinator of the EU-funded BioVoices project, which provides a platform for all the stakeholder groups who need to be involved in delivering the bioeconomy. Werner Bosmans, policy officer for the circular economy in the Sustainable Production, Products and Consumption Unit in the Directorate General for the Environment in the European Commission, and joining us again, David Newman from BBIA and YPACK coordinator, Shema. A very warm welcome back to two of you and a very warm welcome for the first time to the rest of you. It's good to have you with us. This will be a very interactive conversation. I've asked our speakers not to make any more opening remarks. We just want to dive in. I have some questions for them, and I will also keep an eye out for your questions. Remember, you can write them, as most of you have been doing till now. If you wish to speak, raise your hand and I'll try and give you the floor. And if you do have any more questions for our presenters, I'll try and squeeze those in as well. But we have quite a lot of ground to cover. So a very warm welcome to all of you. And Werner, perhaps I could come to you on this, first of all, because David described for us right at the beginning in his presentation how the YPACK project and the solutions that have been developed fit into that bigger picture. He presented a number of challenges and he was forthright in enumerating those challenges. And I just wondered, from your perspective, how you see these types of solutions within the context of the transition to the circular bioeconomy. Would you agree with David, who said this is one of the things we need to do? This is a key. There isn't just one silver bullet, but these products really are central. What is your reaction to what you've heard?
I thank you, Jackie, but if you allow me, first of all, I would like to congratulate the consortium for this very interesting results. I mean, I'm very happy that I'm joining and that I see what they have achieved. So that is the first thing. The next thing on context, and that is what David tried to explain, the overall context. There are many things with what I could completely agree with David, and it's very clear that there's not a silver bullet solution, not one solution to the problem of plastics, of plastic littering, and all environmental impacts that goes together with plastics. A couple of other things where David went a little bit too short into the discussion, I think. Recycling is not a scam, for sure not. Recycling goes up with quite high figures since about 10, 15 years in Europe. And if David is going to cite American figures, it's not what we are about. We are talking about European Union and what we are doing. And you probably all know that we have a highlighted objective to make all packaging recyclable or reusable by 2030. We're working hard to that, and we're very committed to achieve that objective. Now, of course, composting and biodegradation has a big thing. And then there's one thing that I really would like to understand, because through the presentations, I thought there was a lot of terminology confusion between biodegradation and composting. And David said we should maybe ban the word biodegradation. Well, I wouldn't go that far, but it should be clear what is meant. The last speaker very clearly talked about composting and home composting, as taught somebody else as well. Some other people talked about biodegradation, which very often could be understood as biodegradation in the open environment. And then you have a complete different picture, because then you're talking about litter and things that are not collected and that are just not composted in a controlled environment. And we really should make the difference. And I'll leave this opening till here, but I can say many more things, obviously.
Yeah, absolutely. We'll come back to the issues you've raised and discuss those many more things over the next 50 minutes or so. But Chiara, for you and working in this area and on a project that brings all these stakeholders together, how do you see the role of the sort of products we've been hearing about over the last half an hour or so in that transition?
So it's one of the components for the transition to a circular, sustainable bioeconomy. I really congratulate me too to the results, and also for this wonderful presentation. I completely agree with the project officer saying, with the policy officer saying that there is a lot of confusion. And so I'm also do agree with David saying that there is a lot of confusion about terminology. And this is one of the points also of our recommendations when we will close BioVoices, will be sure one of the points that we will underline, the terminology, because people don't understand the differences between all these terms, biodegradable, compostable. Yesterday, we organized another event with the chapter of BioVoices together with the, let's say, word of the investors and so the European Circular Bioeconomy Fund and other stakeholders and the startups and spin-offs to understand how to support them to reach the market. I always talk about bio-based spin-offs and startups, so in this economical world. And yesterday they underlined the problem. It is not clear at all what does it mean sustainability. Sustainability has a lot of meanings, and we don't have one single way of understanding sustainability. So, and this is not well communicated. People understand the different things. I have to add that when we talk about bio in Italy is double more difficult, because when we talk about bio in Italy, we talk about bioagriculture. So to make people understand the difference of bioeconomy, bio-based, and that it is really different from the bioagriculture, that is something really, it's a niche of this word. So the terminology is something that is a barrier for the consumers to understand and then to make choices, thinking when they approach these products. So I completely agree with all the comments and speakers.
Thank you very much. Chema.
I want to tell you both, first of all, thank you for joining us. It is true that there is a confusion in the terminology, but the terminology that we have used is exactly, is meaning exactly what Werner was saying. Our intention is never been only to be able to develop compostable, industrial compostable packaging, but also knowing that there is this issue of let's say, accidental dumping into the environment of some of the packaging, that the recycling strategy will never be able to tackle entirely unless we really restructure completely our society to do so. Our intention in the project has been to develop packaging, and therefore we have been selecting components that would not only biodegrade into these industrial composting conditions at high temperature, that we know that some biopolymers like polylactic acid kind of fulfill, but also using components that would biodegrade in home composting conditions, in soil, and in marine environments. In fact, we are testing all these different scenarios of end of life for the packaging that is being developed, and we have selected components that specifically meet these criteria. So this in no way, form, or shape, the message of the YPACK is not to the people that they could litter because it biodegrades into the environment. That is a very clear thing. But we want to make sure that if for whatever reason this is happening, we are not going to have materials in the environment forever. So we know that PHAs are known to biodegrade in the environment, and this is our there are a lot of concepts that we have been developing and concessions that we have made in the project, but in the end, the packaging should be ideally made entirely of PHA based from waste.
Gemma, could I just follow up? And really, it's a question to all of you in terms of the challenge ahead. What for you was the most difficult challenge during the project? And what do you now see as the biggest challenge to get that take up, that upscaling, that widespread use of this packaging? I know you've already licensed the technology, I believe, to an external company, so you're already on the road. But what has been the biggest challenge, and what lesson do we learn from that, and the biggest challenge for the future?
Yes, as you say, the technology, at least one of the developments that we developed, one of the things that we did was fully compliant with the legislation. And this is what we call the YPACK 23 and also the film. And these elements are already being trialed by different industries, and some applications have already been driven and they are in the market because of that. Some of the most, let's say, adventurous or let's say more experimental components that we have used in the project still need to be regulated. But regarding the question that you asked, Jackie, about the challenges, the challenge is being to get all this food chain aligned in the same direction, and actually resolve some of the issues related to scaling. Because although Antonio said that we don't want the people to replace the equipment, it is true that it's very difficult for companies that are used to business as usual to adapt, to really orient their, let's say, their recipes, the traditional recipes with traditional processing equipment, to really challenge some of the problems that we encountered during scaling up. So the scaling up, in fact, has been the main issue.
And remains the biggest issue for you now. David, I'll come to you in a moment. Gemma,
yes, correct.
the biggest issue?
It remains to some extent. For instance, the film is now kind of solved. It can be scaled basically at any volumes. The cast extrusion before thermoforming also, but the thermoforming is still a little bit of a challenge because the equipment needs to be adapted. And even though we have worked with a significant amount of material, these 3-4 tons that we have aimed at the project at an industrial scale disappear in nothing. So that is the main challenge, to get with the 4 tons that we were planning, get there, right?
Thank you. And David, you wanted to come in. Please do react to what you've heard. And for you, the biggest challenge now to take this, as you say, one of the solutions, but to take this and really take full advantage of what's been developed.
Can I firstly come back to Mr. Bosman? Mr. Bosman, I'm looking at your own graphs here from the European Union. 29.1% of plastic waste was collected for recycling in 2018. But you can't see this, perhaps 9.4% was effectively recycled. 9.4, whereas 12.4 went to energy recovery, 7 went to landfill, and the rest were exported. That's what I mean when I say that plastic recycling is a scam, because if you consider exporting to Turkey or Malaysia plastic recycling, then you live in a world which is not real, Mr. Bosman, and I don't live in that world. I call that dumping, and I call that an illegal criminal behavior. So that's when I say that plastic recycling is a scam. Now, Jackie, to come back to your question, listen, we have to do everything. And at the moment, what we are doing is we're focusing on scams. So we're focusing on increasing plastic recycling a little bit, but we're actually not focusing on the biosphere, which is where our food, water, air, and our health comes from. We can't have a healthy planet and healthy lives without healthy soils. And so materials like Gemma and others are making, and I'm involved in other projects, are part of that cycle. And that needs to be recognized, and the policies need to be put into place to ensure that with bio-waste, food and garden waste, those materials go back to soil. Now, those materials, the composting and the anaerobic digestion plants of Europe cannot become a dumping ground for packaging. They can only be the receptacles and materials which are suitable for their processes. And that means there's a limited role for these materials. There's a limited role. It's a 5% role, but it's 5% out of the 100% which we need to solve.
Thank you. I will, Werner, I don't want to get into a ding-dong on the recyclability issue, but I would in a moment, Werner, like to ask you if you think perhaps until now there has been too much emphasis. Scam, not scam, I'm not going to get involved in that, but too much emphasis on the recycling and not enough on these other solutions. But we'll come to that. But Chiara, first, if I can ask you, in terms of the challenge, as you see it, the challenge you faced in your work through the platform so far, and how you see the challenge ahead to really realize the full potential of these types of products.
So I have to give you some example. Through BioVoices, we have collected already, after 2.5 years, more than 300 samples of bio-based products from European companies that are producing bio-based products. And we have, so now this show that we went around Europe showing citizens, consumers, these kind of products. And they were really amazed from these products, to see, to touch them, to also to smell them, because they was really fascinated to understand how they are produced, because now people want to know, want to have an understanding about how they are not just interested about knowing that it's a sustainable or environmental friendly product and so on. They want to know, to have a clear picture about the traceability of this product. So this is very important, education and information. More than communicating a generic, let's say, environmental friendly product, we see that the people really understand to know how this product can come to them. And so these show that we have, and we hope that in the near future we will be able again to travel around Europe. We miss it, and we miss the people, and we miss faces. Yeah, after so many months. So after BioVoices, we will continue this path through transition to bio. It's another Horizon 2020 project. And this approach about communication and awareness on a bio-based product will be emphasized, especially on the territorial level.
Yeah, there is a question here, which may be for you or maybe for Bettina if she wants to come back in. Which type of customer and consumer demographic do you think is most likely to be the most successful early adopter, i.e. moving beyond the sort of eco-warrior types? What sort of consumers do you think will, I don't know whether our research tells us the answer to that, Bettina, does it?
Yeah, indeed. What we see is that it's not so much about the demographics, because across all countries, the demographics was not the most influential variable, but actually it's more what they know already. That's why indeed there's confusion. Consumers do not know, is this, can I plant this? Can I throw it to for the general bin? Many consumers around Europe do not have these compostable or organic waste bins. So each of the characteristics of the YPACK project was appreciated in different ways by consumers, and that's what determines the clusters of consumers more than demographics.
Thank you very much. I'm going to take more questions in a little while, but Werner, I wanted to come back to you, and as I say, without getting too involved in your tussle here with David, but just in terms of the policy environment that will enable the best possible use of these types of solutions, do you think we do need more of an emphasis in future on compostable materials? I will use that word, given the terminology debate, in contributing to a circular economy, redress the balance a little bit. And also on the innovation side, do you think our regulatory framework is good enough, agile enough, fast enough for some innovations? Because I think I'm right in saying, I'll check with Chema in a minute, that, for example, the active layer, the part that would extend the shelf life of these products, isn't being used at the moment because of some regulatory restrictions. So two questions, really. Enough emphasis on compostability as part of the solution? And number two, does the regulatory environment help rather than hinder these types of innovations?
Jackie, I'll shortly answer on the second one because it's an easy one for me. I don't know enough about the regulatory barriers that this project had encountered to pronounce me on that, so I would need to see that in detail. Which is clear that legislation doesn't always help, just in general, and in innovation, and we are continuously working on that to improve it. But I cannot give a concrete answer on the particularities of this project. I think that's obvious. On the broader question, what are our objectives? Well, we have a big objective, and it is very clear in the European Green Deal of sustainability. It's been an objective of the European Union since a long time. And we have translated that in a circular economy. And what does that mean? A circular economy is to keep your products and materials as long in life and use as possible, because that's good both for the economy and for the environment. Now, if you can reuse your materials, it's an obvious one. If you can recycle your materials, you keep your materials, you keep the value of the materials, you can reuse those materials. And then if you compost them, well, there's a lot of value already that's in the materials that's lost. So there is a thing that we need to look at. What is the concrete role of composting there? Well, we have done, of compostable packaging, we have done one study on that. And that is something where this project is not looking at, but okay, a project cannot look at everything. How will the consumers react? They have compostable packaging. In which bin will they throw this? And how will we make sure that they don't mix it with normal plastic, or that normal plastic then after a while doesn't get mixed with the compostable plastic and gets thrown away in the food waste bin? So there's a lot of consumer confusion there that we should look at, and we don't have a solution for this yet. It's still a big open question mark that needs to be tackled. What I can tell you is that on this cross-contamination, it's a real problem. In Italy, they're doing that very well. They've set that up very well, so they have solved the problem. Not very clear if that we can transfer this solution just like that to other countries. In Germany, for instance, organic recycling, all the firms that are doing these industrial facilities, or almost all of them, they simply refuse all plastics. Not just normal plastics, but as well compostable plastics, because it complicates their composting process of others. It's for them, it often goes together with a degradation of the end composting material. So it's not so easy to see and to solve that. I would like to say something.
Sorry, Werner, just to interrupt you for a moment, because there were two questions directly related to what you said. Somebody, Cinco de Vogel, pointing out in the south of Germany, compostable bioplastic is forbidden to be disposed in the biowaste bin. We get serious penalty when the biowaste collector finds bioplastics. What actions is YPACK taking, or you taking, to get acceptance of the disposal of bioplastic in the biowaste bin? That was one. And the second relates to your comment about Italy. In Italy, we use the term compostable on bags and packaging, and figures from the Italian Composters Consortium show 83,000 tons of compostable plastics out of 101,000 tons are composted without problems. Shouldn't we follow the Italian example? I just mentioned those, you've half answered them already, but they both directly link to what you were saying. But please.
Well, one thing, there are several issues that we can do at the European level, but waste as well is very much something that's regulated, not even at national level, but very often at local level. And that's a legal construction that we cannot just go around. That is what it is. I mean, Europe cannot just impose things when member states or local authorities have the competence and do that. We are seeing how we can deal with composting at the European level, and then we're looking at that at this very moment. It's at least in the field of packaging. We will come up as well with a communication on biodegradable and compostable plastics in general. What would be ideas on how to deal with that? And as some has already said, biodegradable plastics should never be a license to litter. That should be extremely clear, and I heard that from some participants that they agree fully with it. Because even if it's something biodegradable, it will remain in the environment too long time, and it still will cause harm. It might cause less harm than conventional plastic, but it will still cause harm. So there, it's not a solution. So we really need to look at the composting, how we can deal with that.
Let me turn. I want to turn, David. I'll come to you in a moment. I wanted to turn to Chema just on that point about compostability. I think the product does comply with the sort of within 90 days that degradation. But on this broader question, Chema, if I might, of innovation. And was I right in what I said about you can't use the active layer at the moment? What is the issue in terms of making sure that the sort of innovations you're working on, that we have a regulatory environment that fosters them, doesn't hold them back? And then I'll come to you, David.
Yes, so very quickly on your first question, yes, it composts within the composting times. So this has been proven already, so that's fine from that point of view. It also biodegrades in the environment. It is clear that it takes a few months, but it's actually going on, the testing still. But this is something that we already knew from the PHAs when we started the project. So it was kind of a guarantee because it's been proven over and over. Regarding the legislation barrier that we encounter in the project, and to me it's been a kind of a frustration already for a number of years, is the active packaging developments, where we incorporate active components in there that are within the directive, But because still in the European Union has not released, as far as I know, a positive list of substances that can actually fulfill and put into practice this directive on active packaging, this development that we have done that will in fact guarantee the shelf life extension of the products that are actually safe, that are in accordance with the directive, will not be able to be pursued commercially because of this list that doesn't exist yet. And active packaging is still not a reality in Europe, whereas it is so in other latitudes, in US, Japan, etc. And that was the main legislation hurdle that we have encountered over the project, which is in a way is a pity because a lot of money has been spent in research in active packaging technologies. And even at the commercial level, many companies even have got dossiers approved by EFSA, but some of these elements are still not listed. So there is no, this directive has never been put in practice.
And just on this question, before I turn to David, he raised it as a big issue at the beginning. I think it was the first point David made in terms of challenges to get bio-waste collection right. On the other side of it, we have this issue that was raised by one of our audience about the acceptance of the disposal of bioplastic in the bio-based bin. Is this something that you're tackling? Is it, or how do we need to, what do we need to do to address that? Gemma.
Sorry, say that again. I thought you were asking with David.
No, it was to do with this question about it. You know, you can't put bioplastic in the bio-waste bin. Are you addressing these issues? Because it was a specific question.
Yes, okay, I understand now. Well, not directly in the project, because as Werner was saying, is in the end, it's a 3-year project with a lot of challenges. And we cannot really deal with everything. But we know that, for instance, Catalunya, in Spain is the only region where there is the brown bin for the organic waste, and this goes into composting plants rather than in the landfill. David also mentioned, and I think Werner as well, that Italy is a very good example where this can be realized. Germany is probably the anti-example because they are in favor of mechanical recycling, and organic recycling doesn't seem to be an option. But this has to be tackled in the end. If we really make packaging out of organic waste that comes actually from waste, from food waste. Even in the project, somebody questioned Antonio Vicente, why did we use cheese weight? Because in the project we wanted to have a technology that was sufficiently standardized to scale up. But in the origin of the project, we started with fruit waste, with also municipal waste. In fact, every type of waste right now is known to be able to be converted into plastic packaging, into bio packaging.
David, you wanted to come in, and can I ask you, as part of this, to pick up on this point about a regulatory framework that really fosters innovation in this area and doesn't hold it back?
I mean, you know, I'm a naysayer if the non-English speakers understand that, and please accept, Mr. Bosman, my highest respects for the work which is being carried out there in the Commission. And wherever I travel around the world, Europe is the model to which everybody looks, and they copy-paste European legislation. But this is also why what you do is very important to get right, because other people will copy it, whether you have legislative jurisdiction over them or not. And so to two questions. The one around innovation is that we haven't really got our ideas sorted out very well, Jackie, because, you know, for example, DG Grow and the BBIJU, here they are stimulating with billions of taxpayers' money the research into all the products which Chema is making here, which, you know, I'm involved in with other projects with him. Fantastic. And we're coming up. We can even now make bioplastics out of CO2. So we can strip CO2 and use them as a basis to make materials. Fantastic. But then probably we find that there's a legislative or regulatory barrier to actually using those materials. So we need to get that sorted out. That's beyond my capacity to understand and to answer here. But it's complicated, but it needs to be sorted out. The second question around bio-waste is it's also complicated. It needs to be sorted out because there's a lot of vested interests. There are countries which have technologies which are probably not suitable at the moment for compostable materials, but they don't want to change their technologies. That requires investment. That requires changing ways of working. 2/3 of all the biowaste in the whole of the EU is actually at the moment collected and recovered in Italy. 2/3. Okay, so if we can learn from any country, we can learn from the Italian example.
Thank you. Chiara, perhaps I could turn to you now, and please do comment if you wish to on this question of an innovative environment, an environment that fosters innovation. But there's quite a lot of specific questions, which I'll come back to with Chema towards the end if there is time. And I see a hand up. I'll come to you shortly, Dania. But there's a more general question from Dimitris Kostabadidis, who says, what is your opinion about the best way to promote this type of packaging materials in the EU and at member state level? Some countries, as we've heard, like Germany, have policies to promote fossil plastic production in general, and this creates a drawback to your aim. Should the EU, should member states offer incentives to promote the production of these material to have a better final price to the user? What do you think policymakers need to do in order to really promote these types of solutions? Chiara.
So it's a very tough question, how to promote. For sure, we need incentives, and we need a good awareness of the policymakers. I have to say that during these years, we organized almost 70 workshops around Europe with stakeholders, as you know, from the quadruple helix, so research, representing business, policymakers, and citizens of civil society in general. The hardest stakeholder to get involved is the policymaker. Usually, policymaker just came up at the event, at the workshop. They say what they want to say, and then they disappear. But they don't listen. That's the hardest part. Co-create together with the other stakeholder solution means to stay around the table and discuss, understand what could be the solutions. So first of all, the awareness to the policymakers in general, from the local level to the highest level. So this is the first point. And then a lot of education to the citizen, to the consumers. We are preparing many materials. If you go to our website, biovoices.eu, we have a lot of material. We have a very nice, so we have a good partner that is doing a very good communication on social media that go to a general public, from the very young, but not only. We have more than 6,000 followers under BioVoice. That is a very good number as a European project, because we really understood that the education, so info education, cards, serious games are the key to go to the heart of the consumers.
Thank you very much indeed, David and Chema, and then I'll come back to you, Werner, because I want to hear their views on this question in terms of what more the EU member states can do to promote these materials, this question of incentives that's been raised from the audience. David, what more, if you think they can do more in terms of creating the incentives, what would you like to see them do?
Well, you might not know, but for 15 years, I ran the Composting Association in Italy. So 10 years ago, 15 years ago, we saw all this happening before the rest of Europe. And so we made some very, very clear decisions there. And it's not about money. It's not about pumping huge amounts of incentives into a system. It's about actually getting the rules right and making sure they're respected. And we asked ourselves a question, and I'm going to ask you, Mr. Bosman, this question. How do you get biowaste back to soil without plastic contamination? Because at the moment, 2/3, as I said, of biowaste is collected in Italy across the EU. And they do that with very, very low contamination because they use the type of materials that Chema and his team have been making here. And across the rest of Europe, we see contamination levels going to soil with plastics that are between 5 and even 10 times as high as in Italy. Now, fortunately, there's still small volumes because we don't have biowaste collection everywhere. But what are you going to do in 2023 when you get hundreds of thousands of tons of plastics going to soil with your biowaste? So if you answer that question, then you can sort the rest of it out, because you can only have one answer to that question. Okay, and when you have that answer, well, then you have to do regulations. You don't need to put money at it, but you need to do regulations. I was in the European Parliament last week just talking about this with Mr. Pellegrini's team.
Okay, lots of questions coming in, so I'm going to stop you there. Chema, on this question, Werner, then I'll come back to you. But on this question of things policymakers can do to promote the use of these types of materials that you've been developing, what would you like to see from Werner?
First of all, I'm sorry, but I keep on saying, David, you please call me Werner as well, because I feel the only one that's called me being Mr. Bosmans. And I know that you're doing that on purpose, but it would be much nicer to say just Werner. Of course, the legislation, you're referring to legislation here, and that legislation on biowaste, and a huge amount of biowaste is coming up. Of course, that's because we, as the European Commission, we have proposed and negotiated that by 2023 we need a separate collection on biowaste. And of course, we do that because we're convinced that's a good thing. Plastic contamination obviously should be the lowest possible. What is the best technology? Well, for you, the answer is crystal clear. I'm not sure that everybody thinks alike. But suppose that it is the best solution to put up compostable bags, then we should do that. But be aware, if you only want to make composting materials and the only outlet is bags, then you have a very limited list of products that you can do. But on this one, about everybody agrees that compostable bags to collect biowaste is a good idea. So it's a non-controversial issue. In general, though, we should look at life cycle assessments, and I see that this project often talked about it. I haven't seen any results of the life cycle assessment, but I assume that you have a quite good one. It is not the case with all bio-based products. It is not. And that's one of the things that we will look at. We just started a new study on bio-based plastics to see just how sustainable it is. By the way, as well, we want to look at the content of bio-based plastics, because very often the content of bio-based plastics is very low in bio-based materials. It's very often mixed with fossil fuels. So we want to look at that and have some clarity. And we might as well look at the sustainability criteria. We don't say that we're going further in it, but it's a study that's doing that. Because if we use this kind of things that are claimed to be better than fossil fuel-based plastics, well, we should know about it, and it should be clear. And if those things are better than the alternative, so than fossil-based plastics, we have already written in the plastic strategy that we need to look then to the necessary incentives and promotion to do that.
Thank you. I'm going to, Chema, ask you just in terms of what you want from the policymakers, and then I'm going to take a number of questions that are quite specific, so we'll rattle through them if we might, but I'd like to come to as many of them as possible. But a broad thought, Chema, in terms of the incentives, what can be done, what should they do to promote these as part of the solution? And we're going back to that acceptance, and Werner saying lots of studies into precisely some of these key issues. What do you want from Werner?
Well, I think, Jackie, you said it yourself. The only option, apparently, for the circular economy strategies has been mechanical recycling, which for me is an anti-natural way of actually managing the materials, because everybody knows that plastics derived from petroleum have two characteristics that are completely against this mechanical recycling strategy, which appears to be unique. One of them is that they are there to be forever. And the second thing is that once you reprocess them, they begin to degrade. So they are actually poisoning materials potentially in a general, let's say, a scenario where the recycling is the only way to manage these materials. So in the same way as you are, or we are today, putting all this effort in mechanical recycling and getting the strategies to mill materials, to clean them up, which 40% of the energy is just to clean the materials before recycling, and all these things, if we could really generate scenarios to make these bio-based and compostable materials able to get into composting conditions that by milling them before, etc. And then we adequate the cycles of this composting to make sure that they are completely turned back into carbon that is usable. Then this is the answer.
Okay, Chairman, a number of very factual questions about the projects and results, which I'd like to rattle through with you, if I might, to try and answer as many possible. What is the capacity for packaging production? What capacity do you currently have in terms of units per month? Is YPACK ready for mass adoption? Can it scale quickly enough? And when does it become financially competitive and viable against non-compostable? And linked to that, someone saying, could we cover a concrete business question? Is Y23 currently available for purchase? If so, where? I mentioned a licensing partner earlier. Could you comment on those two first, and brief answers if you would, so I can get as many of them in as possible?
Yes, of course, this is the typical question. We are managing at the moment or securing volumes for 15,000 tons a year of the capacity, which is the beginning, but this is all a network of projects and efforts being done at different levels, where people are actually building plants to produce PHAs out of the sludge and organic, the solid fraction of the organic waste, municipal waste. There are many actions there, many plants that are coming into production. And all of this needs to be, of course, sorted out. But there is sufficient volume at the moment available, at the commercially available, and even with food contact status materials that allowed us to really start putting this into practice. But the real advantage and value is what is coming after. What is coming after is the cheaper and cheaper way to produce PHAs out of the everyday residues that we actually produce. And then is when these volumes, when these technologies like a mixed microbial culture, etc., come into production, then we are going to see all of these applications with sufficient capacity to be tackled.
Thank you. Another question here. It's great to learn more about YPACK and the materials that were developed. Do like their origin of life aspects and wide possible application. The question is, were the end of life processing parties involved as well? I'm thinking AD and composting industries, but also more traditional recyclers. Did you secure their buy-in? Asks Rolf Seegers. Chairman again. Sorry, these are quick ones, all about the project.
Well, yes, the end of life scenario that we are promoting here is the organic recycling. That is the clear one. We don't want the people to litter, even when we can prove or demonstrate that there's going to be the biodegradability in the environment. The organic recycling is the road that actually fits into the full bioeconomy or circular bioeconomy scenario. And that is our main aim here. We have not been trying to find ways to recycle those materials. I'm not saying that it's impossible, but again, the same way as trying to recycling let's say, with sustainability, traditional petroleum-based plastics, it is also a nonsense or an anti-argument to try to recycle a single-use material, which aim is to be back into the soil as soon as possible.
Yeah. One more, and then I'm going to take one from the floor, and then I'd like to come back to all of you to try and draw some conclusions about the way forward. Scaling also replies supply of materials. This is from Alan Verka. How do you see, Chema, developments in security of production capacity of PHA from organic waste developing in Europe? What would be a good amount of supply? Brief one, if you would.
Okay, so again, this magic number of 15,000 tons a year production capacity is what the initial company that has taken over the technology is promoting, and what the customers consider a sufficient volume to actually consider seriously or to take seriously the proposal, right? But of course, we need to get at least today, the plastics for packaging are 40% of the full production of plastics, which is about probably closer to 400 million tons a year. So 40% of this to be replaced is a lot of plastic. So this has to go little by little. And then we see that there is niche applications that I think David mentioned before. If we can target 5-10% of those applications of plastics being today used in the packaging area, which is, of course, the packaging is the main issue, because you have the lasting life is from 15 minutes to 6 months, and then it becomes waste. So this has to be solved.
Okay, take one question from the floor, and then I want to ask about priorities for Horizon Europe and follow-ups to this project and your key priority for the future. But Tanya, Tanya, can you hear me? I've unmuted you. A quick question, if you would, please.
Okay, I would just give a comment to Chema and congratulate on the amazing results for just 3-year projects, because I do remember when they started, and I have followed up the whole process and the project. So this is amazing. What have you achieved just for 3 years? I'm talking about a research point of view and industrial also. My question is, considering that the material will be industrially available not very soon, but is it possible to have it for some research purposes? This is the first question. And the other one, you have developed blown film grades and thermoform grades. So do you think, considering that rigid grades are taking a big amount in the food packaging industry, do you think that this could also be one part of
okay,
future
quite detailed, and we're almost out of time. So, Chema, I'm going to ask you in 30 seconds to answer that question, and then I want to come back to everybody else. I'm sorry, but I know some of you need to leave on time, so we need to finish on time. Chema, a quick one if you would, and then I'll come back to you, Chiara, first.
Yes, thank you, Tanya. That is correct. I mean, the big challenge that we tackle at the project, at the initial, within the project, was to develop thermoformable solutions, because injectable are known, but thermoforming, which is largely used by the food packaging industry, was not available, and I think we have been able to achieve that. So is this material available for research? Just contact me and I will put you in contact with the right person for that.
Thank you. Okay, we are almost out of time. Sorry, there are a few other questions. We'll try and reply to those afterwards if we can, maybe, Chema. But Chiara, I want to come to each of you, and I want to start with Chiara. In terms of the future, and I have one specific question and one general. The specific is, as we look to the Horizon Europe, the new EU research programme for the new budgeting period, what for you should be the priority in this area? Where can we get maximum EU bang for bucks, as it were? And overall, what is your key priority to build on the success of this project and these types of solutions and address the challenges we've been facing? So a priority for the research area and EU funding, and an overarching priority to really build on where we are so far.
I think that the Green Deal is already a very good answer from the Commission, and also the call for the Green Deal, Horizon 2020, that is still Horizon 2020, because we have to wait some months to the first call of Horizon Europe. And there is a topic also now about food waste, including packaging. As one of the solutions. And I think it's a very good answer, this first topic, that I think it will be one of the first, and there will be a continuation then in Horizon Europe, about this systemic approach. So the Commission is looking for systemic solutions. So the answer is on the territory. They are calling it cluster. So a territory that is not just a municipality or a region, maybe something bigger, to understand the needs of the territory, the feedstock, the industries. So the answer is really systemic, and could be also the answer for the uptake of the result of YPACK.
Thank you very much. David, your key priority.
Let's get some of the things sorted out, and for example, for example, the fundamental importance of the biosphere and having clean materials go back to the biosphere. That is not recognised at the moment. It's a fantastic step forward that we have biowaste collections in the EU. Compliments. We've got to get them right.
Thank you very much indeed. Werner, your key priority, and do you have one in terms of research, or what should be supported by Horizon Europe in future?
And on a very general scale, it's everything that goes towards circular economy, obviously. related to this project and to composting. One thing is this project where you apparently show that you have a very good LCA. The other thing are a lot of other bio-based materials and biodegradabilities where this is not always exactly the case as with PHA. And we need to sort that out. That's on the one hand. And the other hand is the whole consumer question. So how will they react? How will they know what to throw in which bin? It's a very simple question, but for the moment we don't have a solution. And if you know at what's happening with all the bins that you have at home and the selection, how should I say, the separate collection, the separate throwing away of items in your own household, and you all educated people, and then imagine all the rest of Europe, it's not working out for the moment. So we need a solution for that.
Thank you. Chema, your key priority for the future, and what do you want really, whether it be from industry, whether it be from policymakers, what do we need to do to really build on the success of your project?
Okay, I'll give you just one statement that I received from a retailer in Portugal that is in the project, which I think gives me a lot of hope. And they said 10 years ago, when the customers enter our retailer, our shop, they found a lot of packaging, foods packed into different plastic packaging, and they saw technology. They understood that this was technology to extend the shelf life of products. Today, when they enter into the shop, they only see plastic, a contaminant. And this gives me hope, because only the consumers can actually revert that.
And on that uplifting note, I'd like to thank you all very much for a great discussion. We could have gone on for hours and hours, but unfortunately, people have very busy schedules, so we have to bring it to a halt here. But I would like to thank all our speakers very much indeed. Thank you also to Antonio, to Bettina and Anna for their presentations, their whistle-stop tour over the successes of this project. Thank you, Werner, for making the time and being such a sport in taking some of the challenges. David, thank you for bringing us those challenges, and Chiara for raising some of those crucial issues around consumers and consumer issues and so on. Fantastic stuff. Chema, thank you to the YPACK project. Thank you, ladies and gentlemen, to all of you for joining us. We managed to take almost all your questions, but I had to leave a few more detailed ones out. Apologies for that, but maybe we can get back to you afterwards. One more thing before we go. We have been recording this session, and the final video will be edited and tidied up and then shared with you all. It will be sent by email. Also, just as you leave this meeting, you will see pop up in your browser a little survey about this event. We really would value your opinion on our discussions on the event. So please do just take, it's only, I think, 3 questions. So if you could take a minute just to fill that in before you forget to do it, that would be great. So speakers, as the audience can't thank you in the traditional conference fashion, I'd like to do it for them. And thank you so much to you all. And may I wish you all a very pleasant rest of the day, and stay safe. Bye-bye.